Welcome to helpyourmath.com. Today's video we're going to be covering some evaluations that are to be done without a calculator. And what we're dealing with here is all the inverse trig functions that are common, like arc cosine, arc sine, arc tangent, which are very common. And we're also dealing with inverses comparing to other functions. And so let's walk through the steps of what these mean and how they're assessed, right? Because when we're dealing with inverse functions, we have to remember specific trig functions run on specific given conditional intervals. So let's talk about those intervals. For instance, cosine of theta runs on a domain that is from 0 to pi. So it's inverse. Whenever we invert a problem like the first one here, we have to remember the inverse has to fall between the first and the second quarter. For the function of theta, when we have sine of theta, we have to remember that theta runs from negative pi over 2 to pi over 2. And the reason for this, just like the cosine one, is when we have all students take calculus, right? We know that sine is positive in the first and second quadrant. So for that reason, and remember this is 90 degrees, 180 degrees, this is 270, and 360 as well as being 0. So when we talk about the negative and positive quartiles, this is 0 in radians, this is pi over 2, this is negative pi over 2, and this is just pi. And usually for the case of cosine, the reason why we run in the first and second quartile is cosine is negative in the second quarter, right? As far as sine, we go backward because sine is positive in the first and the second, so we need it to be negative in one of the quarters. So we use the first and the fourth. As far as tangent goes, tangent only runs from negative pi over 2 to pi over 2. So it runs on the same interval as sine does. Now, when we're doing the arcs for these, we have to keep this in mind. So for problem 1, we see we have the arc cosine of negative radical 2 over 2. And what we're thinking is, in what angle do we get cosine to be radical 2 over 2? And cosine of which angle would that be to get radical 2 over 2? That's going to be cosine of 45 degrees. So we have the angle. What we don't have is a sine. And the only possible quadrants we have are quadrant 1 and 2. And the reason for that is cosine is positive in the first, negative in the second. So then the angle has to be a reference angle of 45 degrees in this quadrant. And the reference angle formula in quadrant 2 is 180 minus theta. We know the solution to that, so we have 180 degrees minus theta equals 45 degrees. And we have to solve for theta. So let's move theta over. Or actually, let's move the 180 degrees over. These two will cancel. We have negative theta is equivalent to negative 135 degrees. And so we divide by negative 1, and theta becomes 135 degrees. That covers the first one. Moving on to part B. We see we have the arc cosine of the cosine of pi over 12. Now these are perfectly inverts of themselves, right? So the arc cosine of the cosine, these terms are actually inverses, and it just goes away and we're left with pi over 12. Now this angle would be valid only if it falls within its interval. So we have to make sure that the angle falls within its interval space. Otherwise we would have to find its coterminal. But in this case, we have an angle that's valid for the cosine interval. And so we have nothing to worry about. So this angle is pi over 12 is the solution. All right? Then let's move on to part C. We have the arc sine of 0. And remembering 0, sine runs on the interval of negative pi over 2 to pi over 2. The only value on that interval of sine that gives us 0 is the sine of 0, right? Because the sine of 0 is 0. The inverse of this would be the solution to give the angle, and the angle itself becomes 0 degrees. And that takes care of part C. Now finally we have part D. And part D is the troubling one, right? Because part D gives us the cosecant of the arc cosine of negative 3 over 4. And here what we know about the arc cosine is that cosine of the angle refers to the adjacent over the hypotenuse. And so what we're going to do here is create the triangle based on the quadrant where cosine could be negative. And we know cosine runs from 0 to pi, so this is going to fall in the second quadrant, right? So we have our triangle, reference angles right here. Here's our angle. And the adjacent side takes the negative symbol because the hypotenuse is always positive and the hypotenuse is 4. And the adjacent side is negative 3. So we have to solve for this opposite side. And we use the Pythagorean theorem for that. So you have the opposite squared plus the adjacent squared, which is negative 3 squared, is equivalent to 4 squared. We solve. The opposite squared is equivalent to, plus 9 is equal to 16. We subtract the 9. This goes away. We get the opposite squared is equivalent to 7. And then the opposite side becomes the square root of 7. And it's usually plus or minus, but in this case we see the opposite side as a positive y value. And so this is the positive radical 7. So the opposite is radical 7. Now this is the angle, this gives us our angle based on in here, which is some angle theta, which measures this length. But we don't need the angle, what we need is the cosecant. And if we remember cosecant, cosecant is the inverse of sine, right? Because the sine of theta is equal to 1 over the cosecant of theta. And we're dealing with cosecant of theta here. This is 1 over sine. And sine, again, is opposite over hypotenuse. So cosecant of theta is hypotenuse over opposite. And so what we're getting here is the hypotenuse over the opposite. Our opposite, again, is radical 7. And it's positive, so we have the numerator here being the hypotenuse, which is 4, over the square root of 7. And that's our solution for the last one. You can feel free to rationalize it. Once you rationalize, we multiply by radical 7, top and bottom, which gives us 4 radical 7s over 7. Thank you.